The question that I have is, what are trusses? So far, we've looked at cable systems and beams, right? In the cable systems, say a weight W is supported by a system of cables. The design issue in the cable system is to select appropriate cables, and in order to do that, we had to find the tensions in the cables, right? Finding the tensions in the cable boiled down to considering equilibrium of particles. So here, for example, in this system, the particles would be this ring right here and the weight W, right? In this system, a beam is used to support a set of external loads. In this example, the external loads are the point load P and the distributed load W, right? The beam is supported on a pin over here and a roller over here. To design the beam, we have to find the support reactions and the internal forces at all the points on the beam. We treat beams as rigid bodies, so as we go from a particle to a rigid body, in addition to the linear forces, we also need to consider moments. So in solving this problem, we not only satisfy the force equilibrium equations, but also the moment equilibrium equation. In general, the internal forces at any point on the beam consist not only of the axial forces, but also the shear force and the bending moment. This is a sketch of a typical truss. I'm sure you have seen this in many different structures. They are used in roofs to support the weight of the roof. They are called the roof trusses. They are used in bridges to support the weight of the deck and the vehicles on the deck. They are used in power transmission structures. They are used in cranes, right? And they are used in lighting structures and so on. They are used in many different places. So let's first look at some pictures of trusses used in real structures. So here are some pictures of examples of structures involving trusses. In this picture, we see timber trusses being used as part of a roof structure. All of these are pictures of roof trusses. Here we see steel trusses, and here we see trusses being used as part of a gym roof structure. The trusses in these three pictures are what are called planar trusses. Members of the truss lie on a given plane, and therefore these are two-dimensional trusses. This fourth picture here is an example of three-dimensional trusses. They are also called space trusses. The members of these trusses span the three-dimensional space. They don't lie on a given plane, and therefore they have to be analyzed as three-dimensional structures. Here's an example showing trusses being used in power transmission towers. Trusses are used in this lighting structure. In this third picture here, you see an example of a bridge truss. There are several types of roof trusses. Listed in this slide are some of them. This is called fink, this is called fan, this is called scissors, and so on. Similarly, there are several types of bridge trusses. Some of them are shown in this slide. For example, you have Whipple, bowstring truss, you have Baltimore truss, and so on.